Let's briefly talk about logical operators. In fact, this is a very important topic that we will use regularly. Logical operators and Boolean expressions. Boolean basically means logical or true-false. So those are Boolean expressions are expressions that return value true or false, and those are formal expressions, by which I mean the following. We all use and, or, not in our speech. Now, the way we are using it does not always conform with the way formal mathematical logic, philosophical logic, and programming logic use them. So do remember the formal meaning of and, or, and not. So and or connect two simpler Boolean expressions, and not is a unary operator, so it reverses the truth of its Boolean operand. That is something that is comes after the not something. Not true equals false. First of all, there are two version Boolean values. So let me restart my idle. And say not true. Notice that true is capitalized. So not true equals to false. This is a basic Boolean expression. Not is an unary operator, and true is a Boolean expression. Now, not true is false. And for example, true and false is equal to false. So this is an example with an AND operator. On one side we have true, on the other side we have false. And the AND operator takes two operands, that is two values on the right and on the left. Now true and false means false. This is just a formal definition of an AND operator. Okay, let's talk about AND operator in detail. You can examine this table in your own time, but there is a nice way to summarize it. AND operator returns true only if both ingredients, both operands, are true. Like true and false gives false, false and true gives false, false and false gives false. The only way to get true is if each, left and right, operands are true. And OR operator kind of behaves the opposite way. The only way to get false if you have is if you have false or false. This is sort of an awful way to put it. It should be false or false. So let me show you a couple of examples here. So false or false will return false, and false or true will return true. So this is just something to remember. Remember how they function. There is something called short circuit evaluation. Why it is circuit? Well, computers are electric beings, most of them anyway, not all of them. And in electricity, this formal mathematical logic also has an application in circuits. But let us understand the essence of it. So OR operator, if the left operand is true, the compound operand is the compound expression is true. Well, that is because for an OR operator, it's enough for one of the operands to be true. And for the AND operator, if left operand is false, compound expression is false. Otherwise, evaluate the right operand. Well, how does that make our lives easier? If you are programming a complex Boolean statement, and it is an AND statement between two simpler statements, you put a very simple one to the left and a more sophisticated one to the right, because if the left one is evaluated as true, you don't even have to worry about the right one. And that saves time. In general, short-circuit evaluation saves time, and the way they are written may save tiny fraction of time, but it depends. If you do these evaluations a lot, it matters. All right, and finally, the easiest of them all, the not operator. Not true is false, not false is true. It's a binary logic. Now, people may be unhappy with binary logic, but as soon as you get into the examples, you will see how diverse it is. And if you want a valued logic, sort of, instead people use probability and statistics in some way, which delivers the desired result. All right. So here is an example. X is greater or equal to 10 and X is less or equal to 20. Let me actually switch to idle and try it for different x's. For example, x equals to 5. Okay, 2. X equals 2. X is greater or equal to 10, and x is greater, smaller, or equal to 20. So now my x is a certain value, which I can plug into this Boolean expression and calculate whether this returns true or false. So 2 is greater or equal to 10. That is false, right? 2 is actually less than 10. By short-circuit evaluation, I don't have to calculate the other one. Actually, this one is true. 2 is less or equal to 20. And the result is false. And for comparison purposes, x is still 2. I'm going to copy-paste and replace the AND operator with an OR operator. Take a moment, think what it will do. Now, x is greater or equal to 10. That is false, right? My x is 2. It's still false. But this one is true, and because OR works so that it's enough for one of them to be true, for the whole expression to be true, here we are. And if you like a little bit more sophisticated example, so my x equals 2, y equals 3, z equals 5. Whoa, sorry. X, y, z equals 2, 3, 5. That means x equals 2, y equals 3, z equals 5. Now let me create a random expression, x less than y, and z less than y. What will that return? Quickly plug in the values and figure out the values. So x equals 2, y equals 3. So x less than y, 2 less than 3 is true. So far we're doing well. We have to check the other one. So z equals 5 and y equals 3. That is false. So the whole thing is false. Now, you may be wondering why I decided to put parentheses here. Parentheses in this particular case are not necessary. Each of these expressions will be evaluated before AND, but in general, parentheses are useful. And parentheses actually govern the order of evaluating expressions. Now, let me come up with another example. I'll copy-paste and modify this one. X less than y, or x less than z. So this is a different expression. Now, How do we compute it? What's the order of evaluations? Well, parentheses go first. Here I can do without parentheses, it doesn't really matter. But here the parentheses are important. So first I have to compute the highlighted part. To do that, that's an OR expression. Let's compute the first one. X less than y is true. And x less than z is also true. X was 2, z is 5. And hence, 2 less than 5 is true. Well, for the OR operator, I didn't even have to check the second one because the first one was true. So this highlighted expression returns true. However, the other one is still sadly returns false. Z less than y because z is 5 and y is 3, and hence the whole thing is false.